So I would like to work out problem number 37 in chapter 19. This is on homework 5. And I've copied out the diagram here that's given in the book and placed in the diagram the relative, the resistor values. And what we need to do in this problem is we need to consistently work with the idea of adding up resistors in series and in parallel. And when we have resistors in series, then we have something in this type here, and this is, say, R1 and R2. Then we can replace this with one equivalent resistor, which is R1 plus R2 in value. And things that are in parallel, in this case, there are a couple of times that we have things in parallel, and we have more than one box. And we're going to have two different cases where three things are in parallel. So when we have things in parallel, we know that the equivalent resistor is found by adding the inverse values of the resistances, and then we remember to flip them over at the end. So the key in working on any problem with equivalent resistances that has lots of parts to it is to start with the innermost, most complicated part and then work outward. And so what we're going to do is we're going to redraw this diagram a number of times with individual blocks replaced with single resistors. So I'm going to start with this because it's sort of in the most inner part. So if I start with just that bit, I have here three resistors that are in parallel. So I have this part here, just this part here, where I have a 60, a 30, and a 20 ohm resistor that are in parallel. Those are going to become equivalent to one resistor. And because these were in parallel, 1 over R equivalent would be 1 over 60 plus 1 over 30 plus 1 over 20. And you can get a calculator and do this in decimal if you want, but these are nice, easy numbers with 60 as a common denominator. So that's, if I made 60 a common denominator, I would have 1 plus 2, right? Because in order to get the 30 to a 60, I'd multiply the top and the bottom by 2. And then to get the 20 to a 60, I'd multiply the top and the bottom by 3. So this is going to be work out to be 6 over 60, or 1 over 10. And then this is, remember, 1 over R equivalent. So that means that this single resistor here that replaces this block of 3 has a resistance of 10 ohms. So that's now 10 ohms. So now I'm going to go back to my original figure, and I'm going to replace this box that I have in red with just one whose value is 10 ohms. And I'm going to actually take the time to redraw that because I think it's really important, because otherwise you get lost in what you're doing. So we're going to redraw the whole diagram. And you don't have to redraw it great. It doesn't have to look great. But the key is that I've now made a 10 there. And then it still has a 20 next to it. And then there's a 60 ohm here and a 30 ohm there. Oh, no, that's not right. I think there was I think that is right. Nope, that was a 20 ohm down here. And then the one that we have out to the right is a 10. Okay, so I can do a little bit more work here. So these two are in series, and when resistors are in series, they have the equivalent value of the sum. So these two are going to be replaced with a 30 ohm resistor. So I'm going to then say, well, I've replaced those with the 30, and so I'm going to redraw it again. So now I've got a 30, a 60, and a 20, and then a 10 out here. So now I've got done that 30 by replacing these two 10s and 20s on the top. And now this box here is another parallel box, and it's the same numbers as before. So I have 1 over 30, 1 over R equivalent would be 1 over 30 plus 1 over 60 plus 1 over 20, and I just did the math for those. And so the R equivalent there is 10 ohms. And so now if I think about replacing that box with a 10 ohm resistor, so that's this for that box there. And then there's this other 10 ohm resistor that was hanging out. These two are again in series, and so I've gotten it down to just one resistor, which is two 10s in series, so that's a total of 20. So the final answer is 20 ohms. So the problems like this can become very complicated if you look at a diagram that starts off with a lot of parts, but it's just two different steps that you apply repeatedly. You break things up, you start in the darkest, densest spots, you replace a batch, then you replace the next batch, then you replace the next batch, then you replace the next batch using either series or parallel resistance.